Total knee replacement is a medical intervention used in orthopedic implants to resolve any problem that's represented by a degeneration of the cartilage inside the knee itself. But unfortunately, the satisfaction level of this total knee replacement is only up to 80%, and 20% of the patients are not satisfied with this type of replacement due to a couple of post-operative problems such as functional loosening due to the imbalance inside the implant itself. Based on this feedback, we decided to use a mechanism that will be self-powered and will be implanted inside the implant itself to give a feedback after surgery about the situation, about the load distribution in terms of generated voltage inside the implant. This mechanism is called triboelectric generator. Actually, this mechanism consists of three main parts. The first part, or the upper part, is an conductive electrode. The lower part is another conductive electrode, while the middle part is the PDMS layer. This mechanism actually works based on contact and separation. So once we apply the load on the upper electrode, it will hit or it will touch the PDMS layer, and the electrons will move from the upper electrode to the PDMS, so the current will start flowing between those. And this is actually a good mechanism that matches the walking cycle of the human body inside the joint, and this mechanism works based on contact and separation. So once we implant it inside the total knee replacement, it can experience a cyclic load from the transverse load inside the knee itself, so that will improve a feedback after surgery. So this generator will be designed to cover the whole area of the knee to give feedback in terms of output voltage after surgery, which will give a chance for surgeons to monitor and to develop these implants and to avoid any function loosening that will happen after surgery. Since we have two main positions inside the knee joint, which is the medial position and the lateral position, and in the real life case, the medial position experiences more load than the lateral position. So to detect this ununiform distribution, we decided to divide this configuration into two main configurations, the lateral configuration and the medial configuration, to test the imbalance, which is the main factor that causes functional loosening for this implant. So after performing this experiment by shifting the load toward the medial location, the output shows that the load or the voltage generated at the medial position is higher than the lateral position due to higher load at that position, which is a promising concept that we can detect the imbalance inside the knee to avoid any post-operative problems.